Hello everyone. So today we are going to solve problem number 2366, minimum replacements to sort the array on LeetCode. So it is marked as a hard problem on LeetCode, but I think it should be medium. So let's first read the problem statement. Here you are given a zero indexed integer array nums. In one operation you can replace any element of the array with any two elements that sum to it. That means we can break an element A into its corresponding elements B and C such that B plus C equals A. So they have given an example. For example, consider 5, 6, 7. In one operation, we can replace num set 1, that is 6, with 2 and 4 and convert nums to 5 to 4 and 7. So what we need to do is we need to return the minimum number of operations to make an array that is sorted in non-decreasing order. So when generally we see the minimum number of operations, we think of DP. But here, if you look at the constraints, we see that it is 10 to the power 5. That means DP would not be applicable generally here. So now let's analyze some more examples. In the first example they have given, it is 393. So looking at this, we know that we have 393. So if somehow we break 9 into smaller chunks, this whole array will be in non-decreasing order. So what we can do, we can here break, suppose if we are breaking it in 4 and 5. So this is an invalid operation. How? Because if this is already 4 and we can only break elements, that means we can never, this 3 can never be greater than 4 or 5, and we are required to break into more chunks then. So going like this we cannot solve it. So how can we approach this? So we observe one thing, that the last element should be the greatest. So why not start from the last only? So here we will start from last. So first we will encounter 3, so it's okay. Then we meet the second last element, that is 9, and then we go to 3. So when we are at 9, we see it is greater than 3, and it should be less than or equal to only, ideally. So we will break it in chunks of 3, 3 and 3. And in order to do that, how can we break? So 9 will be first breaked into 3 and 6, and 6 will be again breaked into 3 comma 3. So in total what we need is two operations. So the number of operations is equal to number of parts after breaking minus 1. So suppose this was 8. So how could we have breaked it? So suppose the array was 3, 8 and 3. So we generally would have bracketed 3, 3, then 2. 3, 3, 6 plus 2, 8. What if it was a 7? We would have broken into 3, 3, 1. But we see if we are breaking it like this, then we need to break 3 also. But what else we can do? We can do in, if we are trying to break it, we want to make sure that the number after breaking, the lowest number, is the maximum possible. So we know that we need to break it in three parts because 3 plus 3 is already 6, and this number should be less than 3 or equal to 3. And here we need to break into in one more part. So what we'll do, we will first calculate the number of parts it needs to be break into. Then we'll simply divide 7 by 3 and we'll get 2. That means the smallest part can be 2. So how we'll break it? We will break 7 into 2, 2 and 3. And if we observe carefully, we don't even need to know how we are breaking in exactly. We just need to take care of the minimum element. So suppose this array was 3, 8, 3. We will start from here, the second last element, and we will first calculate the number of parts it needs to be broken, and that will be simply array at I divided by array at I plus 1 plus 1 whole 1. So here it will be 8 by 3 plus 1, that is 2 plus 1, that is 3. So it needs to be broken into three parts. But if it is a perfectly divisible number, suppose it was 9, then we only need to do 9 by 3. So using this way, if we will check a condition, if num set I is perfectly divisible by num set I plus 1, and how can we check it? If this remainder is 0. So here the number of parts will be simply nums at I divided by nums at I plus 1. Sorry. And else, if it is not perfectly divisible, then we'll use this method like this. We will first divide, then add 1. And what would be the minimum number? So in this case, if it is perfectly divisible, the minimum number will be same as this I plus 1. And if it is not perfectly divisible, then it will be the current number divided by the next number. And we will count the total number of parts it's break into minus 1 to our number of operations required. As we can see in this example, here 9 is finally broken into three parts, but we only require two parts to break it into, and our result here is 2. So let's see how to code it. I think the intuition is quite clear by now. So what we require is a variable to get the store the answer. So we will do long answer as 0. Then now we are traversing from backside. So we will start a for loop for that. I equals nums dot size minus 1 will give us the last index, and minus 2 will give us the second last index. And then I should be greater than equal to 0 and minus I. So this loop will traverse from second last till the first element. Now at each step we will check if num set I, that means the current element, modulus num set I plus 1 equals 0 or not. And if it is 0, that means it's perfectly divisible, and we simply need to add num set I divided by num set I plus 1 minus 1. This will be the number of parts minus 1 to our answer. And what will num set I become after the all the methods are applied? It will simply be num set I plus 1. because it is divided into equally in num set I plus 1 numbers. And if it was not the case, then what we'll do, we will first calculate the current. That means how many parts it is breaking currently, and this will nothing but num set I divided by num set I plus 1 and plus 1, because 8 divided by 3, 2 plus 1, like we see in the example. We'll make it long now. Now we need to increase our answer. So our answer will be nothing but current minus 1. That is number of parts minus 1. So we'll add this in our answer. And finally we need to change num set I. So num set I will become num set I, that is the current number, divided by number of parts. And this will give us the minimum possible number of after division. And yeah, that's all. And next we simply return our answer. Let's check if it's passing sample test cases. Yeah, so sample test cases are passing. Let's try to submit it. So it is getting submitted successfully. So let's analyze the time and space complexity for this. So we are simply traversing from last till the first element. So it will be a big of n, and inside the loop we are doing constant operations and constant operations. And for the space complexity, it will be a constant space. So finally we can say the time complexity is big of n and the space complexity is big of 1. For that is all from my side. Thank you and see you in the next video.